Okay, in this video I'm going to continue on with exercise 6C of the book Fundamental Applied Mathematics. We're on page number 165 and the question is 7. It reads, the gravitational attraction of the moon on water at the surface of the earth is enough to move the tides. Find in newtons the magnitude of this attraction on 1 meters cubed of water. Correct the two significant figures, and we're told the moon is 400,000 kilometers from earth and 1 meters cubed of water weighs 1,000 kilograms. So we know, of course, that Newton's law of gravitation says the force is equal to the gravitational constant, the product of their masses, divided by the distance between their centres squared. Alright, so of course it falls off at 1 over r squared, as we say. So let's plug in the information we know. The gravitational constant is 6.6 times 10 to the 11, or 10 to the minus 11. The mass of the Earth is 6 times 10 to the 24 kilograms. The mass of the moon is equal to 7.4 times 10 to the 22. By the way, you should be able to see here, there are 2 powers of 10 in the difference, so the moon is on order 100 times smaller in mass than the Earth. And then we need to divide by r squared. So 1 second, 400,000 kilometers. So there's 400,000. And we need to convert that to meters by tagging on another 3 zeros. So it's 4.0 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. Alright, that is the force that the moon exerts on the Earth. Or the force that the Earth exerts on the moon, it's the same thing. So let's just plug this into the calculator and see what happens. 6.67 times 10 to the minus 11. Multiply that by 6 in fact, times 10 to the 24. Multiply that by 7.4 times 10 to the 22. Divide the whole thing by 4 times 10 to the 8 to be squared, giving an answer of 1.8 times 10 to the 20 newtons. Alright, so that is the force which the moon exerts on the whole Earth. And what we're asked to do is find the, find in newtons the magnitude of attraction on 1 meters cubed of water. 1 meters cubed of water. Okay, so I'm just trying to think there for a moment. Right, we know, of course, from Newton's second law that the sum of the force vectors is equal to mass times the acceleration. So let's apply this on Earth, and we're going to get the following. We're going to get 1.8 times 10 to the 20 is equal to the mass of the Earth, which I said was 6 times 10 to the 24, times the acceleration of the Earth, times its acceleration, which we're finding out. So we get that A is equal to 1.8 times 10 to the 20 divided by 6 times 10 to the 24, giving an answer of 3 times 10 to the minus 5 meters per second squared. Alright, now we know that's pretty small, and I'll tell you why. Just bear with me now and I get rid of these. That is an acceleration 3 times 10 to the minus 5. Alright, so first of all, it is 5 powers of 10 smaller than 1, so it's nearly 1,000,000 times smaller. In actual fact, it's 300,000 times smaller than 1, because there are 5 zeros. Compare that to the acceleration due to the gravity of the Earth, or the mass of the Earth, which is 9.8, one will say. So you can see that it is, well, that is almost 1 power of 10. So this is approximately 10 to the 1. And this is 10 to the minus 5. So you can see there are approximately 6 zeros in the difference, which is 1,000,000. So you could say that the acceleration due to the mass of the Earth on the Earth is almost 1,000,000, or just is over 1,000,000 times bigger than that of the acceleration due to the pull of the moon. So finally, let's use this to see what force is exerted on 1,000 kilograms of water. So F is equal to 1,000 kilograms times the acceleration, and F turns out to be 0.03 newtons. Okay, just bear with me now when I check the answer of this at the back of the book. So we have 6C question 7, 0.03 newtons is correct. Okay, so compare that of course to your weight. So let's just compare that just for the sake of it. Your weight, say if you are 70 kilograms and you multiply that by the acceleration due to gravity. So we'll say the force on a man might be equal to 686 newtons. So it's 6, let me think now, that's 60,000 times bigger. Alright, so thanks for watching. Please pass it on to your friends and subscribe to my channel. Oh.